Okay, this is Mwali, and this is your first flip lecture. So what you're going to do is you're going to watch this at home and take notes from the boards, and then the next day you will come in ready for a quiz or discussion or whatever else to talk about. So your first one is over the International System of Measurements. Okay, this system is a common measuring system throughout the world, mostly uses units from the metric system, and is mainly based on tens. Okay, so over here, our base units for length, and in this system we have base units and derived units. So in this, for the base units for length, you have the meter, which you use a capital M. For mass, you use the kilogram, kg, time, seconds, and temperature, you use Kelvin. Okay? Length, we use the meter. Longer distances, you're going to use the kilometer. Anytime you see kilo in front of a word, it means it's multiplied by 1,000. So a kilometer is 1,000 meters. Shorter distances, you're going to use a centimeter, or even shorter, you're going to use the millimeter, which is 1/100 and 1/1000 of a meter. Over here, mass. Mass is the measure of the quantity of matter. Mass is measured in grams and kilograms, and mass and weight are not the same thing. Mass is, like we said, the amount of matter. Weight is the measure of the pull of gravity on that matter. So if we were to go to the moon, we would have the same mass, but our weight would be different because there's not as much gravity. And then over here, time, and the SI system is measured in seconds. So if you had to make up an equation to figure this out, what would that look like? How many seconds are in a day? Temperature is Kelvin, and you figure out Kelvin, you take the degrees Celsius and you add 273. Okay? So the freezing point of water is 0 degrees Celsius, which means the freezing point of water in Kelvin is 273. So 0 degrees Kelvin is absolute zero. Derived units are area, which is just length times width, so that's measured by meters squared. Volume is length times width times height, so that's meters cubed. And then density is the mass per meters cubed. So this system is important because it's a common system throughout the world that makes it to where when we measure things, we can compare them with other scientists' findings, which if you did the activity today where you chose your own unit, you saw that we had problems when we tried to compare our results.